Throughout this course, we'll be collecting a lot of data in the lab, especially numerical data, measurements. We want to make sure that we're making our measurements as carefully and precisely as possible. Now, one of the measuring tools that we'll use quite often is a graduated cylinder. So I want to make sure that we know how to use a graduated cylinder properly. We kind of take it for granted that, yeah, we can just look at the markings, write down some numbers, but sometimes accuracy counts, and I want to make sure that I'm recording the most detailed measurement possible. So number one, graduated cylinders come in different sizes. They are used to measure volume. You've probably used a graduated cylinder in the past, and if you look carefully, which we will in the lab, you'll notice that like the liquid kind of bends up the sides of the graduated cylinder. We call that a meniscus. When we read a graduated cylinder, we want to make sure that we read to the bottom of that meniscus, the bottom of that curve, which often means then that we have to get down at eye level to make the most accurate measurement reading possible. Step number one, get down at eye level so you can read to the bottom of the meniscus. Step number two, we have to look at the markings on that particular graduated cylinder. Again, they're all different sizes that measure different volumes. Some might measure 10 milliliters, some measure 1,000 milliliters. The markings are all a little different. For example, the two graduated cylinders on the top maybe look a little bit different at first glance, but when I look at the tiny markings, I notice that they mark every milliliter. The top left just has like a big number every 10, 15, 20, 25 milliliters, and on the right, there's just a big number every 10, 20, 30, but all the little markings in between represent a milliliter. Now, first thing I want to do then, when I get down to the meniscus and I identify that low point, is I want to measure every digit I know for sure using the markings on that graduated cylinder. So I look at these markings and I confirm that this is 15, 16, 17, 18, 19, 20, 21, 22, and I want to get as accurate as possible. I'm pretty confident that it hits the 21. I think it's in between the 21 and the 22. We write down everything we know for sure. I am 100% confident that it hits the 21 milliliters. But I don't want to leave it at that. It doesn't feel right. I feel like I can do better. I can tell somebody that it's in between the 21 and the 22. When you make a measurement, you record everything you know for sure using the markings on the graduated cylinder. This one is marked every milliliter. I know for sure it hits 21. But then to get a little more accurate, you get one more spot as an estimate. So I'm going to say point blank. Now I get one spot as an estimate. I'm going to estimate the tenths. And so I want to be as accurate as possible. I think it's maybe right in between. So maybe I estimate 0.5. The last spot in a measurement is always an estimate. We're trying to be as detailed as possible. So yeah, I can do better than just saying 21. 21.5, I think it's right in the middle. But now this last spot is an estimate. So if somebody else says 21.4, 21.6, those are all acceptable, and they would not at all be downgraded on a lab for having data that differ just a little bit at the end. Now, what would maybe lose full credit is if somebody said 21.9, 21.1. I don't know about that. I feel like it's right in between. I want to leave a reasonable estimate, but again, that's within reason. 21.4, 0.5, 0.6, those would all be perfectly acceptable. This gives me A plus. Now, another thing I don't want to do is say, well, if I can give one decimal spot, wouldn't it be better to give more? How about 21.54678? Somebody might say, well, isn't that even better? Like, look at all those numbers. But do we really have any degree of confidence in those numbers? There's not even a marking for the 0.5. Even that 0.5 is an estimate. So how can I reasonably say that, yeah, for sure it hits the 5, 4, 6, 7, 8? And that's insane. That's tens, hundreds, thousands, 10,000s. Like, you're telling me that you can estimate 100,000th of a milliliter? I don't think so. So something like this would also not receive full credit. One spot as an estimate beyond the markings of the measuring tool, which in this case is a graduated cylinder. Now if I look at this other one on the top, I might say, yeah, this is 20, 21, 22, 23, 24. I'm pretty confident it hits 24 milliliters. And then often we walk away because people will say, well, it's right on the line. I think it's right on the line. But if you just say 24, that last spot is the estimate. And I don't want the 4 to be an estimate. I'm really confident that it hits the 24. So you still get one spot. But in this case, we estimate 0. Happy face, full credit. We can estimate 21.0. We do it all the time. Where that's telling the reader that I know confidently that there is a line hit for 24 milliliters. I think it's right smack on the line. I'll estimate 0.0. Maybe somebody else says 24.1 or 23.9, and those would also be acceptable. But just leaving it as 24 is not. Because again, that you're saying that there's a line for 20 and you're estimating 24. That might be something like this, where my graduated cylinder has different markings. Maybe there's a line for 20, there's a line for 30, and there's no other markings in between. And so then maybe my meniscus is something like that. And somebody estimates, yeah, I don't know, I think it's like right in between the 20 and the 30, maybe a little less than half. I'll estimate 24. But that's not our situation. We have a line for 24, and I am confident that it is right on the line, 24.0. Now, often people will complain. They'll be turning in a lab, and they'll say, oh, well, I think you made a mistake in grading mine because I have the same answer as my lab partner, but I got it wrong. And now we'll say, no, actually, there's a difference between 24.0 and just 24. It tells me how detailed the measuring tool was marked to begin with. In this case, the graduated cylinder. No, there's lines for every milliliter, and I'm estimating that we are right on the line. Now, kind of similar at these two graduated cylinders on the bottom. Have some markings, but they're a little different. So, for example, here's the 2, and way up here is the 3. In between 2 milliliters and 3 milliliters, there's more markings. These guys measure to 1/10 of a milliliter. There's markings for the tenths of a milliliter. These graduated cylinders are actually a little more detailed. They're a little more accurate. So I'm going to mark everything I know for sure. Obviously, I know for sure it hits the 2. Then this would be 2.1, 2.2, 2.3, 2.4, 2.5, 2.6. And I am confident that it hits the 2.6. Now, I can even do better. I think it's in between the 0.6 and the 0.7, I get one spot as an estimate. So maybe I'll estimate again that it's right in the middle, and I'll say 0.65. My lab partner said 0.64, 0.66. All of those are reasonable measurements. Again, what I can't do is say 2.658734.9. No, that's too many estimates. You get one estimate beyond the markings of the measuring tool, which always means that we have to look closely at the markings of the measuring tool. So here in the last one, I'm at 6 milliliters. Way up here is 7. So all these markings in between are the tenths again. I'm confident it hits the 6. This would be 6.1, 6.2, 0.3, 0.4, 0.5, 0.6. Yeah, I think it's on the 6.6. And if you think it's right on the line, then you'd say 0.60. And that gets you full score. But if your partner says, oh yeah, 6.6, done. Not done. Because the last spot in any measurement is the uncertainty. This is like saying, I don't know that it hits the 6.6. It's saying that my graduated cylinder might look something like this. Here's the line for 6, here's the line for 7, and there's no markings in between. So maybe my meniscus looks, I don't know, something like that. And I can say, well, yeah, I know for sure it hits the 6. It's somewhere in between the 6 and the 7. Maybe it's a little over halfway. I'll estimate the 0.6. And so there definitely is importance to putting that 0 at the end of your measurement. It shows how detailed the marking tool is, and then we put that 0 in to indicate that we think the marking or the measurement is right on the line. I will be using these graduated cylinders all year long, so we'll get lots of practice in making accurate measurements.